How's it going, Mr. Tori? Today we'll be finding the integral of 6x squared times e to the 3x. Alright, so taking a look at the function, we see that it has a product form integrand. That means that it would be most appropriate to use integration by parts on this specific function. So let's assign f of x and g prime of x. Usually you want to assign f of x to the monomial. So yeah, now let's find f prime of x, which would be just the product form, which would be 12x. And then let's find g of x, which would equal the integral of e to the 3x. And we could just do a quick u substitution to solve this. We let u equal 3x, and then from here du dx equals 3, du equals 3 dx, which then dx equals du over 3. And then we could just rewrite the expression again as integral e to the u times du to the 3 over over 3. And then we pull out the constant, which is 1/3. And we know that the integral of e to the u is just e to the u. So we bring back 3x in x. So we bring back what we substituted u for, which is 3x, and we get 1/3 times e to the 3x, or e to the 3x over 3 plus c. But we don't need the plus c for right now. So now that we got all our components, we're ready to apply the formula for integration by parts. So we get f of x, which is 6x squared, times g of x, which is what we got here, e to the 3x over 3. And we have that get subtracted by the integral of gx, which is this number, times f prime of x, which is 12x. So now, looking at this, it seems that we're left with another indefinite integral. So we integrate by parts again. However, before we do that, let's take out the constants in this expression, which is 12 over 3, and that would be 4. So we take out 4 from this expression just to simplify it. Alright, so now we integrate by parts again. So we can assign f of x to the monomial, which is x, and then this is going to be g prime of x. So g of x would just equal the integral of e to the 3x, which, as we saw here, is the same thing. It'll equal e to the 3x over 3. And then f prime of x would equal 1, pretty much. And then we got that. So we just apply the formula for integration by parts. And what we get is 6x squared times e to the 3x over 3 minus 4. And then here's where we write the formula. So f of x, which is x, times g of x, which is e to the 3x over 3, subtracted by the integral of g of x, which is e to the 3x over 3, times f prime of x, which is just 1, so we don't have to write that. And then right here, okay? So what we could do now, we have to find the integral of e to the 3x over 3, and we could just use this u substitution for that one. So let u equal 3x, and then du dx is equal to 3. So then du is equal to 3 dx. And then dx is equal to du over 3. And then integral e to the u over 3 times du over 3. We take out the constants, so we take out 1/9. And it's the derivative, the integral of e to the u is just e to the u. So it's 1/9 e to the u du, which equals just e to the u over 9, which equals e to the 3x over 9. So that is the integral of this. So we come back here and plug everything in. So we got 6x squared times e to the 3x over 3 minus 4 times quantity x times e to the 3x over 3 minus e to the 3x over 9. So from here on forth, it's just going to be simplification with algebra. We can distribute the negative 4. So we rewrite it. So I drew a little line here. So we distribute the negative 4, so negative 4 times actually, before we distribute negative 4, what we could do is we get all the common denominators for this part. So we would get x e to the 3x over, and then multiply the whole thing by 3 over 3, so 3x over 9 minus e to the 3x over 9. And then we could distribute the negative 4. We get 6x squared times e to the 3x over 3. We distribute the negative 4, so that'll be minus 12x e to the 3x over 9 plus 4e to the 3x over 9. And then what we could do is just make this have a denominator of 9, and we could just multiply this by 3 over 3, so equals 6x squared times e to the 3x, and then multiply by 3 all over 9 minus 12x e to the 3x over 9 plus 4e to the 3x over 9. We come here and rewrite it as 18x squared times e to the 3x minus 12x e to the 3x plus 4e to the 3x, and all of this is over 9. And then looking at the terms, we see that we could take out e to the 3x out of the numerator, so we could just rewrite it as e to the 3x times 18x squared minus 12x plus 4 and all over 9. And that is our answer. Or that would be our answer, however, plus c. And then that's our answer. Alright, now it is time to find the derivative of what we got. Alright, so looking at this, we know we could pull out a constant, which is 1/9, and then we could use the product rule to find our answer. So we pull out 1/9, and then d over dx, e to the 3x, 18x squared minus 12x plus 4. And we know that the derivative of c would be plus 0, so we could get rid of that. So now we have this, and we could just apply the product form, which would be, let's rewrite this. We apply the product form, which would be the derivative of this, which is e to the 3x, times that plus the derivative of that times this. Oh yeah, and since we already applied the product rule, we won't need this derivative sign anymore. So now it is time to simplify. So the derivative of e to the 3x, e to the 3x is in the e to the g of x form. So e to the g of x would be just e to the g of x, which is e to the 3x times g prime of x, and g prime is pretty much 3. So that would be this. Then multiplied by 18x squared minus 12x plus 4 plus the derivative of this. And that would just be 36x because of the product, not the product, the power rule. And that would be 12. This would be 0. So we got this times e to the 3x. So now we have this, and then everything times 1/9. So now that we have this, we can start simplifying. We got 3e to the 3x being distributed to 18x squared minus 12x plus 4, and then plus e to the 3x 36x minus 12. And then all times 1/9. All right. So now we could just distribute these numbers. So 3 times 18 would get us 54. 54 e to the 3x x squared. 3 to the e to this times that equals 36 e to the 3x x. This times that equals 12 e to the 3x. All right, and then plus this times that equals 36 e to the 3xx minus 12 e to the 3x. All right, that's a long expression. But okay, so now we could bring back the 1/9, so it'll all be over 9. But also, we see that this and this, negative 36 times e to the 3x plus positive 36 e to the 3x times x. These two would equal 0. And this equals 0. So what we're left with is just 54 e to the 3x x squared over 9. All right, so we can simplify this. 54 divided by 9 would be 6. So we get 6 e to the 3x x squared. And if we rewrite it, we get 6x squared e to the 3x. And that was our original problem. And we're done.